In section 3.2, number 39, we're going to use this formula of the area of a circular sector to find the value of that unknown quantity. So our quantities are area, radius, and theta, the angle. So I have area and the theta, so I need to find the radius. So I have area equals 1/2 r squared times theta, and I need to get r. So I'm going to solve for r before I even put in numbers to try to keep things neat. So to solve for r, if I multiply both sides by 2, that will help me get rid of this 1/2. The 2 and the 1/2 cancel, and then I have 2a on the left, and on the right I have r squared theta. I still don't have r alone, so to get r, the term with r by itself, I need to get rid of the theta. So I will divide both sides by theta, and I get 2a over theta equals r squared. And again, I should remind you that this theta is always in radians if we want to use this formula. Luckily in this problem I'm given theta in radians, so I don't have to worry about converting it from degrees. Alright, but I still don't have r alone. Now I have r squared. I still need to get r by itself. So to do that, I will take the square root of both sides. I don't have to worry about a plus and minus because r is a radius, so it's always positive. So now I have r equals square root of 2a over theta. Which, I'm just going to switch it around. Now I can plug in my numbers. The area I'm given is 16.5 meters squared. And I have a 2. All over theta, which is 7 pi over 6. Okay, so that's actually an exact answer right there. But I am going to, this is a point, and this is a times. I want to grab a calculator and get an approximate answer and just round it. So let's get my calculator out. And I have, let's do square root of, and then in the numerator I have 2 times 16.5. And in the denominator I have 7 pi divided by, divided by 6. Close that. So I have the radical of the numerator divided by the denominator all inside the radical. Close that second parenthesis to say all of that's inside the radical. And I get 3.0006, which is approximately 3. And the meters, this was meters squared, but it's in the square root, so when I take the square, I'm left with just meters.